Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer, your most fun you can have legally at any age.
Look at all the stuff that was going on. All ages.
All ages? Yeah, tons.
All the fun you can have.
All the fun you can have.
Yeah. See all the stuff in the intro? That's an intro.
No, there's like games, there's like robotic xylophones, there's
we gotta step it
camera
up.
sliders.
We were doing show and tell, and I was saying how we have to compete with Disney and all of the things that are out there to distract us all.
Yeah.
Free stuff, pay stuff.
Fortnite or whatever the game is that all the kids are playing, which I don't know.
Stuff that makes you hungry, stuff that makes you not hungry, stuff that makes you happy, stuff that makes you sad. We gotta compete with all of it.
French fries.
Why French fries are good. Okay. So this is our show. We do Ask an Engineer every single week. This is Ask an Engineer.
Ladyada, Mr. Ladyada, Camera Control, the best hour-ish of engineering news, hacking, making, coding, soldering, gaming, and more. We got a fun-filled, totally packed show with lots of stuff, new products. It's not out yet, and more.
Yeah.
Let's kick it.
Yeah, we were going to try to end early, but I think we're going to just do a full show. I'm cutting some segments just so we can get to everything this week, because you're going to see why soon. On tonight's show, the code is XYZ Color, 10% off in the Adafruit store, all the way up until 11:59 p.m. Standard time. You get stuff. Support an American manufacturer. You kind of heard about that on the news. I think they're the new topic of the day, but it was really important for a time for us to have some manufacturing. And by buying stuff from Adafruit, you're supporting that and you get 10% off. We'll talk about show and tell and more, including a very cool video game demo, which you saw, and then Brandon stopped by with a very neat Bluefruit demo, which I thought was cool.
That's cool.
We'll do a recap of Desk of Ladyada, including great search. We got some open source hardware. That's right, stuff from the Adafruit Learning System. We got some 3D printing videos, including a rapid render, which I thought was a lot of fun to watch today. You'll be able to see that today. We've got Eye on MPI this week on Semi is what we're going to show, brought to you by DigiKey. New products, top secret. We answer your questions. We do that on Discord, adafruit.de/discord or discord.gg/Adafruit. We also store all your questions throughout the week on all the different socials and more, and we answer them here live. We do that on Ask Engineer. Are you ready?
Yep.
It's here.
Yep.
All right.
Let's do it.
It's time. Okay, Ladyada, before we go. Oh, no, we're not here. I'll have to go back this way.
That's fine.
Whoops. Our camera isn't on that one. The code is XYZ Color, and you get free stuff. We're going to, you just go adafruit.com/free.
It'll tell you what the free stuff is.
Yeah, it'll tell you. And then we have same-day service. What did you talk about on Desk of Ladyada on Sunday? We did a couple things.
Talked a little bit about the OPT 4048, which is the product of the week. And I talked about how I used Cloud Code to write a cool web app. We have a video that we'll show at the top secret.
Yeah.
Which is, related to me testing the OPT 4048. It uses web serial to read data from the serial port of an Arduino and then plot it on a CIE graph. Something that would have taken me like a week or two solid to get done, or I'd have to assign it to somebody. And it's like, now, it's not worth it, really, if it's like going to take a week of somebody's time. But if it takes 35 minutes for me and Claude to do it, go back and forth a couple of times until got it right. And the web serial stuff worked wonderfully, which is cool because it's been 15 years since I've written JavaScript. And then we also showed off some prototypes and talked about the great search.
Yeah. Oh, before we get on that, so I was thinking, what's the hang up in some people's heads? There's people that I know that are they're pretty sharp, but there is something that they're like, I'll never like AI, but which is weird because there's been the things that they're talking about is actually even not an AI.
Yeah.
Would you call this natural language programming instead? Would that work? Because you're doing natural language. Are you doing enough coding?
It is natural language programming, but the model you're talking to is a large language model.
Yeah.
Whereas natural language processing, I think they were trying to come up with heuristics and like grammar that would let you understand it.
Turns out transformers are the way to do it.
Just extremely large matrices, right? Yeah. Just massive, massive matrices, which is almost every morning I wake up and the first thing I think about is wow, IBM Watson totally fucked up. That's
your first thought in the morning. Oh!
Yeah, I wake up and I'm oh, it's a beautiful day. And
what am I going to have to eat? No, you don't even think about it.
And then I'm wow, billions lost. Right? IBM, but what's interesting is they were so close and then they just...
Watson. Okay.
Figure it out.
So we did that. Right, and then I showed a little thing. I'm doing some show and tell stuff. I have an app because we have all these little rocks,
You really, yeah.
And we have a kid, so we're doing this rock hunt thing. So, anyways, I'm showing this because I think there's going to be some other. Anyways.
Going on a rock hunt.
Yeah, we're doing a rock
Okay,
hunt.
and then for the Great Search.
What did you do for Great Search?
For one of the breakouts, I think it was like the ACS 37S100 or something. 30 amp current sensor. I needed a terminal block that could handle 30 amps, and I wanted a barrier block. So we went to DigiKey, and we found a really nice, low cost 30 amp, 3 terminal barrier block.
Wow.
Yeah, it'll work out. Okay,
and then JP's project pick of the week. JP's been on vacation, so he'll be back soon. Also, workshop. He'll be back soon from vacation.
Well rested.
We hangouts every Wednesday with Noe and Pedro, and then we have deep dive with Tim. Let's do some open source hardware news, which means the Adafruit learning system. I think it's the biggest collection of open source hardware with documentation and licenses in the world. We have
lots of stuff
thousands of open hardware certifications, Ladyada. What is on the big board this week?
Okay, so on the right, Larzio Paint. So this is for the Metro. We were like trying to experiment with like mouse and video and audio output. So really pushing the abilities of the RP2350 with PSRAM, which is on the Metro. So this is an application that's sort of like Mario Paint, but like it's Larzio Paint. But it's basically an audio, synth.io or sampled audio output where you can control what is being played by using your mouse to click around like a screen. So, if people remember, Mario Paint music, this is kind of like that. You've also got new guides coming, updated, and new guides on the new Blockly actions. So this guide is actually the one above your head, is an updated guide. This one was like a PyPortal with like a power brick, and it was using a scheduled action to turn on and off a light. Now it uses Blockly actions instead of the old like what's it called? Modal dialog box actions, which means you can do more. It's way more configurable and way more customizable. And you can also use it with Whippersnapper. So it turns out you can do it all without any coding at all. We've got this awesome solderless toy robot xylophone using our new 8-output solenoid driver. Like the first thing I thought of was like, finally we can do a solderless.
That was the video in the beginning.
Xylophone. That was the video, and the video will be out next week.
Yeah, you'll see us. You'll see us in front of it, and it's going to play some noise. But I just want to do this because
it's cool.
Liz did a nice video. Yeah.
Those little LEDs I added to the solenoid driver to tell you which was firing. It was like a last-minute addition, but I'm really glad I did it.
Game changer.
Game changer.
And when you see it, this is the brilliance of Ladyada that I'll paraphrase sometimes.
What?
No, I'll paraphrase sometimes.
Okay.
So I watch, people do electronics and all this stuff, and I look for similarities from other things. And everybody's looking at the same chips, the same things, but then Ladyada comes along and she does something better, different, lower cost, and better, documented and all that. And that's where I think the future
I try to do like the best you can do.
And I like that because it's almost like a fixie bike or something that if you take any part away from it, it's incomplete. And if you put too much more, it's extraneous. I like that you're able to make it exactly what it could be. Nothing extra, nothing left out. And because you're doing open source, it is like, hey, if you can think of a better way, let us know. But usually there is no better way. There is usually a way, and you find it.
And as you're wondering, why don't you have more solenoid robot like breakouts so I can make this iPhone? We're getting more PCBs as soon as possible. Unfortunately, like those PCBs got stuck in a little bit of a tariff swirl. But we are getting them. It just like got delayed 2 weeks. It just sucks. I know, but they're coming soon.
Yeah, and just like as a heads up, because people are like, oh, the tariff's over. No, you're going to start seeing companies go out of business.
It's not over, and actually,
it is Wile E. Coyote, and then it is dropping. There's a lot of stuff that didn't work out with people getting their stuff and buying and cash flow and all that.
Wait till the end of the show because somebody asks the question and the answer is the company went out of business. That's why. And then last but not least,
new answer to questions like how come this thing that I used to buy from you is out of stock? You're a reseller of it. They're gone.
They're gone.
Yeah.
And by the way, like once a month, the company's out of business.
Okay,
and then last but not least is this beautiful birthday number crown for an 8-year-old and a 12-year-old. So show you both single and double digit birthdays. Have somebody who's 108. I don't know. We're going to have to like do a new guide for that, but we've got you covered.
Watch out, Brian Johnson. You're going to live past 100 and you're going to need this guide to be updated.
That's right. So contact us. But if you have something between 1 and 99, a perfect way to make glow jewelry to celebrate a 1 or 2 digit date.
Yeah. So we're going to play that video, and then we're going to see you on the other side. And because of the way I have to cram the show in, we're going to go right to 3D printing and play multiple videos in a row. So these are all great videos, well produced, good lighting, not like us, which is like, I've been awake for a week. So sit back, enjoy it. We'll see you on the other side. So we're going to do this video of this really cute project with
cute kids.
Yeah. And then 3D printing, and then a rapid render.
And then
we're going to see right in the middle of a new product introduction from Onsami.
Okay, bye.
Here we go.
I'm making a crown, it's one of a kind. A birthday surprise, oh the sparks will shine. A 1 and a 2, standing tall they'll gleam. Turning 12 today, living that dream. I got the solder, my hands a bit bold. The heat shrinks ready, a story to unfold. Bits and wires scatter all on the floor. DIY royalty, now who could want more? Oh watch it glow, yeah watch it dance. A crown of light for this year's chance. But wait, oh no, it's a short circuit show. Fix it quick, cause my lights won't glow. With every mistake I learn a bit more. Persistence is key, that's what it's all for. 12's my age, but skills are soaring. Patch up the wires, creativity roaring. Finally it shines, beacon so bright. My DIY crown lighting up the night. A creation of wonder, it's mine to wear. A piece of magic crafted with care. Oh watch it glow, yeah watch it dance. A crown of light for this year's chance. No more shorts, I fixed the flow. 12 never looks so good aglow.
After years of camera slider projects, our motorized camera slider is finally ready for its next big debut. This is our 2-axis camera slider. We've added 2 stepper motors with high-precision silent micro-stepping drivers to make smooth motion for taking cinematic videos or time-lapses. We've completely redesigned it to combine a dolly shot with panning for creating stunning compound camera motion. These stepper drivers from Trinamic are powered by the Adafruit KB2040 running CircuitPython. We've designed a custom carrier PCB with a TFT display and a rotary encoder for controlling the motors. One of the coolest parts of the project is our 3D printed crank for the rotary encoder. It's like a little helper that we use to set the camera's position when setting up a shot. We have 2 modes, one for doing quick one-shots and the second for time-lapses. While the slider is moving, you can pause the motors and it'll stop when it reaches the end of the rails. The 2 Adafruit TMC2209 stepper motor drivers are controlled via UART in the CircuitPython code. This lets us take advantage of the silent and smooth operation for both motors while controlling each one individually. A menu system guides you through setting up the slider for your time-lapses or cinematic one-shots. The 3D printed parts support 2 aluminum rails, and the 2 stepper motors are mounted to a carriage with pulley wheels that slide along the profile of the extrusion. The design is completely open source, so you can make changes or customize it to fit your project. All of the CAD files, code, and assembly instructions are documented in our Learn guide at learn.adafruit.com. Liz and I are super excited with how this turned out. We took it to our local park to take these shots, and we plan to use it in our future project videos. I hope this inspires you to build your own camera projects, and be sure to check out Adafruit Shop for your electronics and project inspiration. I'll end this with a short finger drumming jam. Thanks for watching.
Hello and welcome to Rapid Render. This week we're taking a look at Claude. Yes, this week we are diving into using Claude to control Blender via the MCP. Everybody on the team has been using AI, specifically Claude, to help do some of the libraries and a lot of the repetitive tasks like GitHub issues or things that are like so repetitive that it definitely is helpful to have AI help to get a lot of those issues solved. Initially, I was super scared to do all of this because it's all via the terminal. What Claude is doing is writing a bunch of Python to communicate. And one of the things I instructed it to do was build a house. So as it's generating all of the instructions for this, you can see what it's typing here. And I love how it's coding all of this. It's all easy to read, just Python. You can see here, it's creating the roof. It starts creating like the plane, assigning materials, like scaling the door. It's like having some errors and then correcting itself and going through how to correct those errors and like how to go into the Blender UI. So this is definitely helpful if you're just learning Blender. If you want to like look for a command that you're not sure of, like where it is in the UI, or have Claude help you find it. So here it is, like, adding lights. It even adds things that I didn't even think about, like having a little picket fence, adding the trees, adding like flowers to the bed. Oh no, I didn't show the end of it. It actually made the flowers, like it gave it petals, it gave it like, but for editing, I did not notice where I cut that out, but it looked a lot better than this. Like I told it to go in and have it build like, to make the walls like bricks. And then you could keep going further from that, but I ran out of, what is it? The tokens, Oh, it's funny. the linked. Yeah. And then the other test that I did was having it create Adabot. So I'm like, all right, take this image and create a pixel or a polygon robot. And here is how it is first building the block and then making the spheres to have the eyes and the antenna. And yeah, this is super cool because you're able to go, while it's generating all of this, you're able to go into your Blender scene and navigate around it, rotate. Of course, it's not perfect. So here's what it ended up with before it ran out of the tokens or the length of the conversation. It is still learning to communicate with Blender. What we've been showing up until this point is, just mesh. There was no way to edit. This is all primitive geometry that you're able to go in and pull a face or edit a vertice or go into your camera and add more lights and have like a realistic render to it.
Yeah, this is really early days to think of integrating Claude or any other model with existing CAD software. I like this use of Claude. A lot of folks on the team are already doing this, and that is this week's Rapid Render. Claude AI with Blender.
Whole bunch of 3D printing and more. You've heard the hype in the news. MCP. What are all these things? What is this new world of computing that Anthropic made up? Find out more. But what's neat is you could start to see how these things are now making things and using the abilities of Blender and more, or KiCad or whatever. So tune in each week. If you're paying attention, some of these startups are going out of business or getting acquired by the week. So a little glimpse, a little time capsule of a time when we all used to type in things and ask the computer to make for us. The code is XYZ color. Let's go over to everyone's favorite segment, Eye on NPI. Here we go.
Eye on NPI.
Eye on NPI, brought to you by DigiKey. This week it is on Semi. Every week, Ladyada brings a new product introduction, NPI, to you. Ladyada, what's the new product introduction of the week this week?
Okay, this week from onsemi, it is the, let me get this right, the ARX 383CS. This is a VGA 1/8 inch global shutter CMOS digital camera. It comes in, I mean, this is like the bottom of it. The top has like a camera interface on it. And this is a global shutter sensor that you can pick and place onto an FPC or PCB at a lens, and it'll give you a VGA global shutter output with a MIPI interface, I2C configuration, really good for high-speed robotics, video capture. You know, anytime that you need to get video very quickly, you want to do maybe AI on it, you want to do some image recognition on it, you need to have really good quality images. So you might be wondering, well, why would I buy this? I could just get like lots of camera modules on the market, like the fabulous Adafruit OV 5640 Breakout. Why wouldn't I get this? Well, these are very good camera modules for their purpose, and they're very popular. The whole family that is kind of compatible. But the problem is that these have a rolling shutter. This is like an image from Wikipedia, which is kind of the classic roller shutter image. If it's taking a photo, if you're using a rolling shutter camera to take a photo of something that's moving very quickly, whether that in this case it's a fan or propeller, but it'll also be somebody's hand or body or motion if somebody's moving very quickly, or a car or a motor or some other actuator. Because the camera reads out the sensor data one row at a time, it'll get desynced because the motion is happening faster than the pixels can come out of the camera. And the camera only reads like one pixel at a time. What's great about a global shutter is it takes the entire photo at once, makes it more expensive, but means that you don't get any flickering or distortion effect because it's like instantaneously taking a photo. And this camera, it's also, what I like is it's fairly fast. A lot of cameras kind of max out at 30 or 60 frames per second. But this one, running at 640 by 480, you can get 120 if you're willing to do 320 by 240 with subsampling, maybe because you're just getting basic idea of what's going on in your frame of view. You can get 245 frames per second. So very, very fast for your mechatronic projects, which is really important. This is the camera. So I showed you like the image of the bottom, but it kind of comes as this like kind of thick chip. Inside is the camera sensor itself in the middle, and it's WCSP or CSP. You would pick and place it onto either your circuit board directly or into a flex PCB. The pinout isn't published in this data sheet. If you want to get the full data sheet, you're going to have to sign NDA. That's not too uncommon for high-end camera and vision systems. But basically, you can configure it over I2C. You provide a couple power supplies, and you get MIPI output, one lane. And that's not too uncommon. And so that kind of imagery can be read by something like a Raspberry Pi or an STM32 F or H7, I think maybe has CSI input. I know that there's an Arduino Pro chip that does that has camera CSI input. Just make sure that you have something that can handle the MIPI/CSI differential input. But if you're kind of doing this high-end robotics, you probably have a high-end chip that can handle it. They do make, if you're like, okay, I don't want to deal with this like chip, I just want to plug in a camera. They do have this Prism module, which is, they kind of say it's not really meant for mass manufacture. It's more to get people, like if you have a camera manufacturer that you're working with, you would tell them, hey, can you make, use this chip instead of the OV series or whatever, because I need a global shutter control. But if you just want to like kind of get started with like, will this even work for my functionality? They do sell this module. You can get it from them or from DigiKey. And this one does have like the pinout, and I think they probably even, I'm sure if you contact them, they'll be like, here's your Linux configuration to get it started on Android or bare bones Linux setup. They also have a larger dev board, which is available at DigiKey right now that you can purchase. And it has like, there's that lens in the middle. I don't know why there's a gigantic plastic piece. Maybe if you want to fit another lens, maybe that's like a lens capture. It's much bigger, but you can wire it more directly into your
Maybe someone
setup.
can find out in the chat while we're doing the rest of the show, because that might be a question.
What the camera lens is? The camera's in the middle. I just don't know what that big piece is.
Yeah, that plastic piece. To me, it looks like it holds something.
I think it holds optional, lenses and stuff.
Yeah, we'll see.
If you're doing robotics, like our pick and place, I was doing the math, it can recognize one component every 100 milliseconds. So it needs to take and place it. It needs to take the photos instantly. And, while the component is moving, it's taking the photo. And so when it gets that image, it has to do it instantaneously. It can't have the motion. It's not going to stop the motor to take the photo. It wants to take the photo while the component is moving through the view frame. Anyways, so the eval board is in stock. If you want to pick them up, they're a little more expensive, but you get everything going. And if you want just a sensor, because maybe you have a camera module maker that you're in touch with, and they can pick and place it onto their FPC, or if you want to just put it directly onto your board and just attach a lens, go for it. It's in stock with 3,000 pieces.
Yeah, and on Semi, DigiKey, what a cool piece of tech. Think about what has to be made to make things. You have to take pictures so fast that a human eye can't even see the thing move. It's taking a picture of something that you can't see move because it's moving so fast. Wow.
Yeah.
And they make it. I guess my only regret
in life, really, only one regret
is I wish we had a video to show. Oh wait, we do. I don't have any regrets. Okay, here we go. Watch the video. This is a good video.
My name is Mark Siders. I work in ICSD within ISG. I'm the Director of Application Engineering. We're showing off our industrial high-speed demonstration platform. There's a spinning disc with images on it. We're doing that to show the strengths of our global shutter image sensors. Right? We've got multiple lines of global shutters. Some of them have larger pixels and come in larger formats, like our XGS product line, shown over here on the left. That has currently an XGS 12 on it. It's a 12 megapixel sensor. We're cropping that down to 5 megapixel for this demo, and that's what we're displaying on the left in color over here. So as you can see, this disc is spinning quite rapidly, but the image that's coming out on the screen looks virtually frozen. And that's illustrating the strength of our global shutter technology. So this sensor allows you to virtually freeze anything in motion. This has a wide range of industrial applications. We use it, you can use factory automation, for traffic monitoring. Obviously, this case showing the license plate, frozen very well in time. Even though it's moving very quickly, you need global shutters to do that, and we have a wide range of sensors that do that.
On MPI.
Okie dokie, before you go off to new product land, population U, XYZ colors and code, 10% off in the Adafruit store. You get free stuff. You're supporting a American company.
Yay!
Adafruit, this has been hit over all of our heads for a while. America, make stuff. We are.
Okay.
And you can save some money. Let's do some products, ready?
Okay.
New product time.
Going on a new hunt. We're gonna find some new stuff.
I'm not scared.
Oh!
I'm slightly scared. Okay.
We've got some big square buttons. You want a big square buttons? You got big square buttons. So show all the images really fast. So these are big square buttons. There's a 16 millimeter, 51 millimeter, and I think like a 40 millimeter. I'm gonna show them all next to each other. They're basically the same idea. There's this like black plastic case. There's a translucent white square in the middle. There's an LED that you can light up. It's like mechanical, tactile, so it's very clicky. Like I said, it comes in multiple sizes, and then that image shows, one person, that first video.
Clickety click.
So it's like click, and we'll get more
Clack.
demos. So let's go to the overhead because I have to.
Clack.
I'll show them next to each other to compare the size, and I'll explain why I have these.
Clack.
Because you're probably like, why do you have these?
Why do you have these? Why do you have these?
Okay, so this is the 44. Sorry, this is 44, and this is the 50. Sorry, I got the numbers wrong. And this is the 60. I think I called it 51. But it's basically 45, 50, and 60. Okay. So now you're probably wondering, Ladyada, why do you have these big square buttons? The reason is that we already had a square button in the shop. But I wanted to fit like an OLED or a TFT inside of it.
Oh.
Like in this space here, because you can remove the white part. I don't know if I'm...
You're going to put a screen in there?
And I thought we could put a screen or something in there. Like there's a little bit of space. But,
you can make a macro pad. You can make a...
I just thought it'd be cool. Like maybe you could put like a 1.5 inch TFT display, something you could press.
Could you put an e-ink display in there? I don't know.
You could put e-ink maybe, yeah. I don't know. I wanted to experiment, but I also thought like, okay, well, it's always, big buttons are always fine.
when the big buttons get big enough, eventually they can be a display.
Yeah. So this is some big clicky buttons. They all have a tactile switch. You can take them apart. So they do have like an LED The LED.
Oh, I know what we'll use it for.
What?
We'll use it for the thing that you just assigned to Tyeth.
That's right. That's what I already did.
Oh, this is about this.
Yeah, these are the buttons.
Okay, yeah, we have a really neat project. Okay, this.
Yeah, I already did. It's already been done. He already bought them.
Oh, okay.
Okay, so right, so it's a clicky. There's this LED. The LED is separate. It's lit up separately, and I'll say the LED is not that. It's not like super bright. If you want, you can replace it with like a diffused, like a 5mm LED. Maybe it would show up a little bit better. Honestly, the light up isn't so great. If you don't want to put a TFT like me because you're not crazy, you can also just put a cutout, either translucent or paper, and it will square. It'll show up very nicely. But just big square buttons, they're great. This one is like enormous, huge, and this one is like kind of tiny, and this one is just right. So it's big square buttons. We also, of course, have the 33mm one, but that one is much too small, I think. Okay, so that's buttons. Let's keep going.
Okay. Next up, Ladyada, we've got this thing. What does this thing do?
Okay,
Oh.
so these are, and that goes with this.
Yeah.
So this is, you asked for this. This is a
I wanted it.
This is a USB cable with USB-C in the end, where the USB-C rotates like any direction, 180, 180. So
Yeah,
it's like,
you'd be surprised.
rotate all the way around
You
360.
need this for all sorts of things because everything has a USB-C, and sometimes it's camera stuff, sometimes it's lighting, sometimes.
And you're always like, I want it to go out at a
Yeah.
weird angle, and so I was like, fine, I'll stock these for you. So they there's a 1 meter and a 2 meter. I'll say the only thing that's different is this one has the LED like built into the body, and apparently the sample was different than the final ones,
okay.
but that's okay. So the LED is a little bit different. There's the 2 meter version. They're kind of like cyberpunky. They're USB-C on one end.
Yeah, they look
USB
cool too. Look at this.
USB-A 2.0 on the other. So they're not for like ultra high speeds. But here's the thing: that connector can only pass USB 2.0 signals anyways.
Yeah.
It is data and charge. So it's both. You get all 4 signals through, but it works both ways, right? Like you can flip the connector.
Yeah, it's good for like dongles and stuff too. If you have to like move them around and have a laptop and you have to like tuck the dongle and you don't want to like pull the cord. There's a lot of, I found these useful and I just tossed it in my bag and
Yeah.
then we have them.
Okay, so that's that. Okay, and then
Okay, the star of the show tonight, besides you, Ladyada, our customers, our team, and everybody who shares and makes this thing go, is
the OPT 4048, which is, like you said, is the product of the week, which is why the code is XYZ color. So this is a XYZ color sensor. What that means is that it doesn't give you RGB data output. It's like, usually you get like 0 through 255, red, green, and blue. This one actually gives you CIE color, X and Y, which can be converted into color temperature. It also gives you lux output. And it's like a well-calibrated sensor specifically for light temperature reading, which is why it doesn't have like a light on. Like usually color sensors have a reflective light on it that will let you reflect light off of the thing you're sensing. But that's not what these sensors are used for.
I've never seen that word, tristimulus.
Tristimulus.
That's a cool word.
Tristimulus?
Yeah.
Yeah.
There
Isn't
it
there
is.
like a book about that? Like
It sounds like a planet.
The tristimulus
Well, it sounds
problem?
like a planet where everything is made out of threes. Okay.
Yeah.
All right.
Very unstable. Okay, so I can show this on the
Yeah.
overhead. I got just a quick demo that I just threw together real fast.
Tristimulus.
Let's try stimulus. So this is just an ESP32 with it. And you can see, so it's, I'm kind of moving it around, but it can measure the color temperature of the ambient light here, which is 2800, 2900 degrees K. That's about right because we have like fairly warm indoor lighting because we're in a house. And then, what I can do is I can mess with the light since I've got my my phone.
Yeah.
And then when I do this, the lux goes up to 2000. The color temperature gets a little cooler. It gets like 3000, 3100.
Oh, so there was an observation in one of the chats, but I just want to confirm.
Yeah.
Could you test like the LED lighting? Like, could you be able to test LED stuff?
Yeah, like if you're like, is this a warm, cool, and what temperature is
Yeah.
the LED? It's not going to tell you like, I mean, you can use the X and Y to find like what color emission it is, but like the thing it's really good for and what it's really designed for is color temperature of like lighting. So, I think it's actually used, I think a lot of the times, this is, used for sensors, of course, but it's used for televisions and monitors where they want to change, the ambient light will be detected and then they might change the lighting of your device to to make it look better under different lighting, because it's like
When
colors look
it's
different.
dark, you want the dark to look different. Yeah.
You want things to look different under different lighting conditions and different color temperature conditions. So it's a scientific sensor, but it solves the problem very well, and it's very inexpensive. It's easy to use. And we also made a little web app that you can use with this, and we'll show a video after.
I like this. You can do so many things because you get that data and like make music out of it. So many things you do.
Okay.
All right, and that is new products idea.
Yep.
Okay, we're gonna do questions, but first we're gonna do top secret. Someone in chat said that part to the lens, by the way.
Yeah. To the lens. Yeah, it's a lens.
Yeah. Okay, let's do our top secret. Don't forget, go to XYZ Color. We'll do top secret, then we'll go over to questions. We are, let's hear.
Yeah.
We got like 7 or 8. We got a couple lined up, so let's do top secret.
Okay.
Okay, for top secret, I goofed and I only got one of the videos in. So while I'm playing this video, I'm going to get the rest of the images in. That's what I had run out of time.
That's okay.
for.
You have time.
I got a little bit of time, so watch this video. We'll be back on the other side. We'll also play the little clip from the Great Search video game. Ladyada, what is this?
Okay, so I'm working on this OPT 4048 Trisimulus sensor. This is a color sensor that can read RGB data and then decode it into CIE, X, and Y. So that's useful for like when you want to do like chromacity or color temperature and lux sensing. So, I got it working with the library that I wrote, and that's all well and good. But then I was like, man, I wish I had like a way to plot the data. And so normally, plotting data, especially on like a just like XY Arduino plotter, is really complicated. But I worked with Claude, and we made this cool JavaScript page. So if you come out, you'll see. This is actually hosted on GitHub. So what's nice is that it's all JavaScript, hosted on GitHub, and it uses Web Serial, so I can connect to this device, and then the Arduino sketch prints out the data, and then it's plotted here really nicely. So the CIE, the lux, the temperature. I'm kind of moving it around, so it's jumping. But it's, kind of like a warm white color. And then, I was testing this and I was like, well, how do I test other light colors? I don't actually have any gels here. I was like, oh yeah, I could just like put the sensor up against it, and you'll see that the little dot follows it around.
It's training itself on synthetic data.
I know, it's funny. So this is really neat because something like this web page would have taken me I know JavaScript I could do it, but it would have taken me like days. This only took like 25, 30 minutes.
You got hardware to make.
Go back and forth. Yeah, I can focus on the hardware. And so what's neat is I'm thinking like maybe we'll do this for more products whenever we want to plot or show the data. Instead of just having the Arduino or CircuitPython REPL output, maybe we'll just say, hey, look, connect it up to this GitHub hosted Web Serial demo, and you can really quickly test the sensor and get real data out. It's like it used to be when you bought dev boards from companies to do this, you had to run like Delphi programs that only run on Windows. So this is pretty amazing. I love it. So this sensor's gonna be coming to the store soon.
Okay, sorry, I was talking over the video there, folks. I was like trying to get the questions lined up. Whoops, I had the...
Yeah, I know. I was like, why are you talking?
I know.
Usually you're yelling at me.
I'm exhausted.
Okay.
That's why I'm just like, let me just see the questions there. I'm going to ignore that one. Sorry, Lon. I gotta keep moving. So here's a little clip from the video game. That's right. You'll be able to play it soon. Go to our Discord, go to the Great Search channel.
Secret password.
And you can get the URL and the password to the game and play it. So, Ladyada, you've been busy, very busy. What have you been making?
So this rendering is for that ACS 73 something. It's a 30 amp current sensor for high voltages. So I needed that barrier terminal block.
Okay, and then next up?
This is the massive breakout that I designed for that BQ25798 max power point solar charger that we covered on IMPI like 2 or 3 weeks ago. I really like the chip. It's really a beast, but like it kind of does everything. So I designed a breakout that I think covers everything you could possibly need or want to do with this board.
Okay, next up.
This is a request. Somebody was like, well, I want to drive a lot of those LED nudes or filaments in a row, and they add up to like, 24 volts or more. Do you have a boost converter? And I'm like, you need a constant current boost converter. We don't stock any. So this is a constant current boost converter. It's not only for LEDs, but I kind of designed it for LEDs, and I can do up to like 38 volts and up to 200 milliamps. Although it can't do 38 volts to 200 milliamps. It can do like 25 volts or 38.
Okay, next up.
This is what I worked on today. This is a breakup for the SI 4732 AM, FM, long wave, short wave, and single sideband also, I think. Radio receiver with antenna outputs, or antenna inputs, I2C control. I could put on a crystal there. I got a headphone output with a headphone amplifier. I think kind of everything you need to do to make kind of all-in-one digital radio that's I2C controllable.
Okay, and last but not least, until you send me the next one.
No, I'm caught up.
Okay.
This is a little STEMMA QT breakup board for Raspberry Pi. There's a little header on the back there.
Yeah, it looks like a corner of a board. It's like,
this is the corner. Yeah, it fits into the corner of your like Pi because I was getting really tired of using socket headers, and I wanted something with an LED on it too, and like a separate power supply so I could hot plug stuff. This will let you hot plug I2C devices.
Okay, and that's questions.
Yep.
You can no, sorry. Oh man, I gotta get into it. That's top secret.
This is top secret.
Okay. Where'd I go? No, right here. So if I don't put the
Things are really falling apart here.
It is. I have to do a green
But
screen
we only
test.
have like 5 minutes left.
Yeah, I know, but you'll just watch me skid across the finish line. So if I don't put the green screen and test something, that doesn't get the background. Anyways.
Yeah.
Let's go over to begging for money, and then let's do questions. Oh, I get it. I'll answer the other one there. Okay. First up, Ladyada, why don't you read these while I get this other one going?
Okay. Why does a VEML 770 have two STEMMA connectors? Because you can chain I2C, and SparkFun did that with their design. I was like, that's a really good idea. Okay. So you can plug it into I2C, and then you can plug another device on the other end.
All right. Next up.
Can we put 294 screens in a row on this module? So the Raspberry Pi can't drive that many screens because it's just not going to be fast enough. You really want an FPGA driver. You could drive like 8 screens. That's a lot. But if you want like a gigantic billboard, you need like a driver board for that.
Next one. I can disappear us. Tell me when.
No, this is just about like the PMW 36100, 3610. Okay. So this is like a sensor. It's not really easily available. It's used in optical mice. I've never used it. I've kind of looked into like what would it do to get a breakout, and it was like really complicated, hard, and they were constantly discontinuing some of these chips. I've heard that they're fairly easy to use. I think it uses I2C or SPI, and there's lots of libraries available.
Good. Next up.
Okay.
Oh, Brandon.
Using the NR52 chip, and they want the antenna circuit without using module. I wouldn't do it. Really, like it's not that much cheaper than just using the module. But if you do want to use the antenna, they have Nordic has a great forum board, and I just talked to one of their apps engineers, and I said like, "Here's my design," and they're like, "Do this, do this, do this, and you'll be good." And then like I tested, we did like a lot of distance tests, and we basically got like 80-90% efficiency. So I was happy considering like it's a very tiny antenna. It's in the middle of the PCB.
All right, and then this person asked,
"What is that PCB holder?" That's Panavice.
Yeah.
I think it's a 213. Bad news. I think they're out of business.
So
if you really want one of these, you should get one. We don't have any.
All right,
we're out of
so
stock.
here's the
they
thing.
won't reply to my emails anymore.
Yeah, so
that's kind of the end.
Here's the thing that you all should check out while you're in the chat, because I haven't checked in like a week. We were trying to get a hold of them because we're like, hey, we want to pay you money to get your goods.
That we've been. It's one of the first things we've stopped.
Yeah, this is I've personally shipped so many of these when I was the only shipping person.
They're great.
So the thing that we're noticing is companies going out of business, not saying they are, but it seems like they are, have certain things that start to happen. They stop responding to emails. The website certificate doesn't get renewed, and then it says it's not HTTPS. then you can't really go to the website because browsers don't like that.
Then like, the emails start bouncing.
And then emails start bouncing, and then all of a sudden, like you get a letter later that says it's in liquidation or something. So
I'm not saying that's happened. I'm just saying they're on that path. And they haven't proven to me that they're not going to continue on that path.
Not saying that's happening, but every company that has gone out of business, that has happened.
This is the beginning.
The thing is, I did email some people that do manufacturing in the US, and I'm like, hey, maybe there's something going on with Panavision. Maybe you can scoop them up and continue operations in the US or whatever.
Not Panavision, Panavision.
Yeah.
Panavision is the camera company, which
Panavision used to be the camera company that was at 150 where old Adafruit was.
I just want to start like rumors.
And they do
camera stuff.
They do
camera rigging, but they don't do.
Yeah. And like remember the time we showed like one old timey Radio Shack stock certificate and everyone said we bought Radio Shack. I still get that. So we'll see what happens. I'm going to do a little bit of investigation, but
not looking good.
Yeah, and this is the thing. There isn't just this isn't just do legislation or giant cultural and society changes by social media. It takes a while. So
the other company, I think it was publicly. It was the motion sensor that we stopped. Leap. Yeah. It's actually public. They're in bankruptcy court. They're in receivership.
Which you'd be surprised because like everything is AR, VR, and like they're a very high tech company anyways.
I don't want to like dunk on them too much, but they had this amazing sensor that we sold like hundreds of, and then they discontinued it, and they came up with a different sensor, and then nobody wanted it. It was a very weird. I don't completely understand why they made this decision.
Happens. Okay, and then I'm going to read this final one, and I will answer it. This person says, basically, you have this open source camera slider, but is it really open source because the file format for the 3D printing is not open source? Well, the thing is, a file format is a file format. It's not a binary blob. It's a file format. So it doesn't matter what the open source hardware definition.
The CAD files are actually in text format. They're not binary either.
And let's even say if they were, imagine they were. As long as you can import and export the file that was originally made for this design that the creators are publishing, it's fine. And if you really want to just like save yourself some internet snarking, ask yourself, what is the intent of the person that made this? Did they put their files somewhere? Did they do open source license? Did they do all those things? If the answer is yes, then they really wanted to be open source. They're not pulling a fast one. And if there was an easy way to make a universal file that worked everywhere and everything, obviously everyone would do that. But what we're doing is we're putting the file up in the format that we use to create it. And in this case, maybe it's whatever CAD file. But you can import and export ones. And we worked with EagleCAD a long time ago before they were bought by Autodesk. And we made sure it could be XML exportable. So the reality is you're going to be spending a lot of time doing things in and out of a file format, whether it be open or not. Look at what's going on with AI. What is it, like probably half is just trying to have AI get stuff out of PDFs.
That's all I do all day.
That's all it does.
Yeah.
And like we'll eventually get there. And then, I haven't seen an article, but like isn't AI going to end PDFs? This like very hard to manipulate data format?
Well, we're talking to one chip company. We're actually they're getting close to releasing their data sheets in a MCP friendly format.
Yeah, we're convincing chip companies to make it so you can have all the things in a data sheet in a machine learnable format, so you can do lots of automation with assigning drivers and such. But just it's a good thing to think about, which is what's the intent of the creator. Obviously, Noah and Pedro and Adafruit is doing open source, so
yeah,
I don't know. You're just being. I know what you're doing, and like you're not really fooling us. I read your comment. It's open source.
I mean, you're giving them attention. Maybe we'll just delete it next time.
No, why? I don't care. Okay. We could help someone when they ask this question for the next time.
Okay.
So anyways, that's that. Those are the questions. We'll see everybody next week. Don't forget that this has been an Adafruit production. It's XYZ color, and we'll see everybody next week. I'm tired.
Bye, everybody.
I thought I had a second wind, but I actually didn't.
You had a negative wind.
Yeah, it's just like I'm just gonna.
Let's go.
I'm gonna play this thing.
Let's go put a baby to sleep.
Yeah, it's an infant prediction. Here's your mom's nearby, everybody. I'm gonna play.
Bye.
I'll play the 1 minute clip of the video game again on the way out. Here's my mom's dinner.